The following is from summer 2007, Math 227, final number 2. In this video, I will do part A and part B. I will do part C and D on separate video and part E on another video. Okay? Number 2, a box contains 5 quarters, 3 dimes, and 2 nickels. Part A, 7 coins are selected without replacement. Find the probability of selecting 4 or more quarters. Let's see. So in part A here, we are talking about quarters, right? So in our box, it is being partitioned to 5 quarters and another 5 non-quarters. Doesn't matter, dimes or nickels. Now, we will select 7 coins. Find the probability of selecting 4 or more quarters. Probability that the number of quarters is 4 or more. But you only have 5 quarters. So we are talking about the probability of having 4 quarters plus the probability of having 5 quarters. Okay, which is equals to, let's see. What is the probability of selecting 4 quarters? We select 7, right? Let me write it down. Select 7 coins. So if I select 4 out of 5 quarters, there will be 5. Choose 4 times the rest of the coins, 5 non-quarters. I need to select 3 of them because a total of 7. Okay, over 10, choose 7 plus. The first one there is the probability of selecting 4 quarters. Now let's see what is the probability of selecting 5 quarters. There will be out of 5 quarters I choose all 5 times 5 non-quarters I choose 2 of them over 10 choose 7. Okay, now this will be, if we compute, this will be 5 times 10, and then this one will be 1 times 10 as well, and at the bottom 10 choose 7. Where is 10 choose 7? 10 choose 7, it is 120. Is 50 plus 10 over 120. That's actually 60 over 120, which is equals to 1/2. Oh, that's surprising, huh? It means if you repeat this procedure and again and again, then half of the time will be this case. Either you have 4 or 5 quarters. 50% of them will satisfy that. Now part B. Let's see. A coin is drawn randomly 8 times with replacement. Now once you see replacement means the coin that you choose, after you select that, you put it back, right? You put it back, and therefore the probability of that coin being selected first time and second time are the same. Now this initiates a binomial distribution. Okay, now let's define a variable then. Use the word D. Let D be the number of dime selected. Okay, now this D will be binomially distributed with number of trials 8, and the probability of selecting a dime will be 3 out of 10, right? Because you have 3 dimes and out of 10 coins. So if I need to choose 1 coin, that will be 3 out of 10 chance for a dime to select a dime, right? 3 out of 10 or 0.3. Okay, now the question here, find the probability in part B. Find the probability that of getting a dime twice. The number of dimes you get is twice. Okay, now if I use all the way formula, there will be 8 choose 2 times 0.3 squared times 0.7 to the power of 6. This is the number of ways you can have 2 dimes. This is the probability of having 2 dimes and the probability that the other 6 are not dimes. Okay, and then if I compute this, I think this is 28 times 0.09 times, oh, that's a big number. Do I want to do it that way? That's 0.117649. If I multiply all of them, I will get 0.296475, or maybe I use 8 here. Okay, so around 30%, almost 30% of the time, you will get 2 dimes. Now this is from summer 2007, math 227, number 2, final, number 2, A and B.